let's talk about sum and difference identities with the unit circle. And there's a lot more identities than the Pythagorean identities and the reciprocal identities and the quotient identities that we've been using. But these trigonometric identities show how to find the sine, the cosine, or the tangent of the sum or difference of two angles. So when we add two angles together or when we subtract two angles. And here they are. Here's what the sum and the difference identities are. And the thing about these is that you have to watch out for the signs. So look up above the simplifies 2, and then look down below at ultimately what the identity is. So let's look at how these identities work, and we're going to take a simple one that we already know the value for, and we're going to figure out how to apply this formula. And the first thing, though, that we need to remember is what's the value of sine? And sine is a quadrantal, so if I write this little drawing up there, that might help you remember what the sine of 90 degrees is. And I know for me it's been hard to go back to degrees, and thank goodness on the back we'll hit the radians again. But sine of 90, this is 1, 0, this is 0, 1. So the sine of 90 is 1. So what we're going to do, we know the answer here. Let's see how we get the answer with sum and difference identities. So the first thing that we're going to do is we're going to determine the formula to use. Since we're trying to find sine of 90, we're going to use one of the sine ones. So in the first box at the top of your paper to the left. Second, we're going to choose two angles to utilize in that equation. The thing is, the two angles that you choose may be completely different from the two angles your neighbor uses, and you will still come up with the same values. But the two angles that you pick, they either need to add to be 90 or they need to subtract to be 90 in this case. Then we're going to follow the formula, and finally we're going to make sure that your final answer is written in the exact form. You can check your answer using your calculator. I don't think that I'm going to deal with the calculator part today. But here's how it works. So we've got sine. We want to find sine of 90. So the first one I chose is I said, well, 30 plus 60 equals 90. So we need to go back and we need to think. Oh, and I need to fill it in first before I start thinking about it. So when we use this identity, here's our A and here's our B. So if we follow the formula here, it's going to be sine of 30 times cosine of 60. And then over here, the function's reverse, and the degrees are going to stay the same. Cosine of 30 and sine of 60. And you may want to look at your unit circle again, just because we haven't talked about degrees in so many months, even. But the sine of 30 is 1/2. And the cosine of 60 is also 1/2. Cosine of 30 is the square root of 3 over 2. And the sine of 60 is the square root of 3 over 2. And let me stress once again, this is sine of 30 times cosine of 60 plus cosine of 30 times sine of 60. So now when we come down here, we're going to simplify. 1/2 times 1/2. Well, 1 times 1 is 1, and 2 times 2 is 4. Over here, square root of 3 times square root of 3. Well, square root of 3 times square root of 3 is square root of 9, and what does the square root of 9 equal? It equals 3. 2 times 2 is 4. Once again, we know that sine of 90 equals 1. 1/4 plus 3/4 is 4/4, which is 1. And we already know Sine of 90 is 1. That's how the sum identity works. We can do the same thing with subtraction. If we look to the right there on our paper. By the way, though, as I flip down here for a second, does sine of 30 plus 60 equal sine of 30 plus sine of 60? Let's see. What's the sine of 30 again? It's 1/2. What's the sine of 60? Well, sine of 60 was radical 3 over 2. Does 1/2 plus radical 3 over 2 equal 1? No. When we add these two together, we can't simplify it into two sine functions. We have to use the sum identity. And now that we've seen one, maybe this one will make a little bit more sense. I know the first time you see this, it looks kind of wacky. But over here, 135 is A and 45 is the B. If you do the math, 135 minus 45 does equal 90. What we're going to fill in? We're going to fill in the 135 here, the 45 there. Still the sine function. We're subtracting, and the angle measures aren't going to change. 135 here and 45 here, except that now we switched the functions. Sine was first in the first group, cosine is first in the second group. Well, then we have to remember, well, what's the sine of 135? Well, the sine of 135 is square root of 2 over 2. 135 is in the second quadrant. Do we need to make the square root of 2 over 2 negative there? No, because sine is positive in the second quadrant. Cosine of 45 happens to be square root of 2 over 2. Remember, 135, it's in the second quadrant. Now, cosine of 135. Well, cosine of 135 is square root of 2 over 2. 135 being in the second quadrant, do we need to make that function negative? Yes, cosine is negative in the second quadrant. So this is going to be minus, and then it's negative, square root of 2 over 2. And then sine of 45, square root of 2 over 2. So lots of square root of 2's over 2's. But when we multiply, square root of 2 times square root of 2, square root of 4. And some of you have to write that, and some of you don't have to. Multiplying the tops together, 2 times 2 is 4. And over here, before I get too far along, minus a negative really gives us a positive. And square root of 2 over 2 times square root of 2 over 2 is square root of 4 over 4, because we multiply the tops of the fraction and the bottoms of the fractions. But what is the square root of 4? It's 2. So this is 2 fourths plus 2 fourths. We're still trying to figure out, what does the sine of 90 equal? Well, 2 fourths plus 2 fourths is 4 fourths. And 4 fourths simplifies to be 1. If we look down at the bottom of our page, same idea here. Does sine of 135 minus 45, is that equivalent to sine of 135 minus 45? Well, we said this was radical 2 over 2. And we said this was radical 2 over 2. Does radical 2 over 2 minus radical 2 over 2 give us 1? No. We can't break it apart like that. We need to use an identity to get things to work out. Now, like me, you might have had trouble with the degrees. When we flip over here to the back, the radians might be easier for us. While it might be easier to think of two angles that add or subtract to give you another, if they're measured in degrees, radian measure is what we're more familiar with. So let's take a look at our radian measure here. And let's see if we can find two angles on the unit circle measured in radians that either add or subtract to give you the following. And it says try to come up with multiple pairs. But what I'd like to show you is how I approach this, because for some people fractions is really a difficult concept for you. The thing that I know about fractions is when we add or when we subtract fractions, we have to have a common denominator. So what I see in this problem here is that we've got a 12 in our denominator. So I'm going to write it like this. Common denominator means common denominator means they both have to have a 12 in them. Well, now that I've got the common denominator, do we have any values that combine to be 5? Let's go add to be 5 to make it adding's a little bit easier than subtracting. Any two values that combine to be 5? Like 2 pi and 3 pi? The thing is, when you write it like this, we need to simplify the fractions. And this is where you might need to type in your calculator. When we simplify these fractions, the values that we find need to be on our unit circle. So if we simplify 2 12ths, we get pi over 6. Is that a value on our unit circle that we're familiar with? Yes. 3 pi over 4. If we simplify, so what you can type in your calculator is 3 over 12, which is pi over 4. Is that a value on our calculator? I mean on our unit circle? Yes. So I start with the denominator, and then I work backwards. Now, if you picked, and don't write this down, but if you picked, say you picked 4 pi over 12 plus 1 pi over 12, it's true, we can simplify that, and we get pi over 3. But do we know what pi over 12 is when we're finding values on the unit circle? We don't know that one. So, and that's fine. If you pick it wrong, that's okay. It's just that this one's not going to work because we don't know the values for pi over 12. What I said is, I said, try to come up with multiple pairs here. Again, the thing about these is that we want, like I said, more than one. Can we come up with something that subtracts to b? But when we still do subtraction here, we still have to have common denominator. So two values that subtract to be 5. So I said, how about 8 pi minus 3 pi? 8 minus 3 is 5. We already have common denominator. And then can we simplify that a little bit more? Well, if you type in 8 twelfths, if you use your fraction button on there, we get 2 pi over 3. Is that a value that we can figure out from our unit circle? Yes. 3 pi over 12 is pi over 4. And it just so happens we can figure that one out as well. So we have to find values that link back to our unit circle. And if we get it wrong, that's okay. Let's try another one. Like 23 pi over 12. So somebody volunteered here to try one, and he said 21 pi over 12 plus 2 pi over 12, and definitely 21 plus 2 is 23. So if we simplify 21 over 12, well, 3 goes into 21 7 times, and 3 goes into 12 4 times. Do we know 7 pi over 4 on the unit circle? Yeah. 2 pi over 12 is pi over 6. Do we know pi over 6 on the unit circle? Yes. We could do one with subtraction also. And just for time purposes, I did 26 pi over 12 minus 3 pi over 12. And when we simplify that, we get 13 pi when you divide by, did I do this one right? Divide by 2, 13 pi, divide by 2, 13 pi over 6. And then 3 pi over 12 is pi over 4. And it's a little bit dicey here because 13 pi over 6 is 2 and 1/6. But ultimately we can figure out what 13 pi over 6 is on there. A little bit harder. I like the first value better than the second value. But it'll still work. And it really is the key. If we can pick two values where we can find that, where we know the actual x and y values of the ordered pair on the unit circle, then that is really helpful for us. As we get to pi over 12, and we'll look at this one here. Once again, let's have a common denominator. 3 pi over 12 minus 2 pi over 12 seems easiest, and in fact I couldn't come up with adding personally, but definitely the 3 pi over 12, which simplifies to be pi over 4, and 2 pi over 12 is pi over 6, and we are absolutely familiar with both of those values. But again, just because you pick those two values, the pi over 4 and the pi over 6, doesn't mean that the person sitting beside you or the person sitting behind you is going to pick the same values. It doesn't mean that you can't get the same value, the same answer when you finish. You should, but you don't have to have the same value as your neighbor. But let's look and see how these work here to finish. And the first one is cosine of 5 pi over 12. And to avoid looking back, flipping your paper back and forth, you might look at your reference sheet, which is pink. And cosine of 5 pi over 12 is up there in our second value. And as I look back here, the first value that we did for 5 pi over 12 was pi over 6 plus pi over 4. So let's use pi over 6 plus pi over 4 when we write this. It's cosine of pi over 6 plus pi over 4. And we're going to fill these values back into our identity. And as you look at the pink sheet, what you see is that this is going to be cosine of some value times cosine of the other value. But since it's plus, we're going to subtract, and it's going to be sine of some value times sine of some value. Can't put that in here, so I'm going to have to write below it. But that's the way we did that on the front page here. So to fit it in, it's going to be cosine of pi over 6 times cosine of pi over 4 minus sine of pi over 6 times sine of pi over 4. We'll go back and use your hand gestures again if you remember them to fill in these values. Sine of pi over 6 and the b, have it 3 over 2. Cosine of pi over 4, holding in your middle finger, is going to be the square root of 2 over 2. The nice thing is, pi over 6 is in the first quadrant. Pi over 4 is in the first quadrant. We don't have to worry about signs, positive or negative signs. First quadrant, everything's positive. Over here, sine of pi over 6 is 1/2. Sine of pi over 4, square root of 2 over 2. So we can get darn close to finishing here, now that we've filled those values in. When we multiply fractions, we multiply the tops of them together and the bottoms of them together. Square root of 3 times square root of 2 is square root of 6. 2 times 2 is 4. 1/2 times the square root of 2 over 2. 1 times square root of 2. 1 times the square root of 2 is square root of 2. 2 times 2 is 4. Nice thing here, we already have a common denominator. We want to write our answer in exact form. That means that we're leaving the radicals in there. And as we finish, we get the square root of 6 minus the square root of 2 all over 4. So we don't know what 5/12 is, but we can come up with our answer by knowing other values about our unit circle. Let's try another one. 23 pi over 12. And then as we look up here, the first one was the 21 pi over 12 plus the 2 pi over 12. Let's use that one. So this is going to be sum of 21 pi over 12 plus 2 pi over 12. And sorry, I should have written a different value there, but if you wrote it down like me, there's no sense in erasing it. I think that I left you enough space on the paper. So if we simplify that, it should be 7 pi over 4 plus pi over 6. And that's what I should have written down. But there's nothing wrong with the 21 pi over 12 plus 2 pi over 12. We can see that equals the 23 pi over 12. So when we fill this in, once again, here's our A and here's our B. Look at your pink paper, if necessary, and this is sine of 7 pi over 4 times cosine of pi over 6 plus cosine of 7 pi over 4 times sine of pi over 6. So once we get the identity filled in, we can figure out the value. 7 pi over 4. What quadrant is that in? It's in quadrant 4. So we need to keep that in mind. Because when we figure out sine of 7 pi over 4, it's going to be square root of 2 over 2, but is it going to be positive or is it going to be negative? And sine is negative in the fourth quadrant. Times cosine of pi over 6, well, cosine of pi over 6, square root of 3 over 2, plus cosine of 7 pi over 4. Well, in the fourth quadrant, cosine is positive, so that's good. And that's going to give us square root of 2 over 2. And then sine of pi over 6 is 1/2. And now we can finish. We multiply the tops together. We multiply the bottoms together. Negative square root of 2 times positive square root of 3 is negative square root of 6. We can multiply those two together. 2 times 2 is 4. Square root of 2 times 1, square root of 2. 2 times 2 is 4. And finally, to finish, we get negative the square root of 6 plus the square root of 2, all divided by 4. On tangent, we have values. We found them earlier. Pi over 12. 3 pi over 12 minus 2 pi over 12, which is pi over 4 minus pi over 6. So it's tangent of pi over 4 minus pi over 6. And as we look at our paper to fill this in, watch out for the plus and minus signs. In the top of our function, because we're subtracting here, this is going to become tangent of pi over 4 minus tangent of pi over 6. All divided by, now it's going to be 1 plus tangent of pi over 4 times tangent of pi over 6. So if you look back at your pink paper, the minuses on the bottom in the original, tangent of A plus or minus B. The minus is underneath. So when we look over to our numerator, we have to go to the sign that's underneath, which is going to be minus. And then the sign that's underneath in the denominator is the plus. That's going to be the hardest part probably for people. And hopefully as we work through this together, we will figure it out. The other hard part is that not everybody knows their sign values. And that's something that we need to go back home and think about, is do we remember what the tangent of pi over 4 is? And the tangent of pi over 4 is 1. Tangent of pi over 6 is square root of 3 over 3. Down here in our numerator, it's going to be 1 plus tangent of pi over 4 is 1 times tangent of pi over 6. Square root of 3 over 3. And maybe you didn't even write the 1 times the square root of 3 over 3, because you know 1 times square root of 3 over 3 is just square root of 3 over 3. And I'm going to start going left here so that I've got a little bit of space. This is 1 minus square root of 3 over 3 divided by 1 plus square root of 3 over 3. What's going to happen is that we need to combine these fractions. So we're going to subtract them on top, and we're going to add them on bottom. If there's any nice part here, it's that there's ones in there. And when we add or subtract fractions, we have to have a common denominator. And our common denominator happens to be 3. And 1 over 1 is the same thing as 3 over 3. Minus the square root of 3 over 3. Down here, it's still 3 over 3 plus the square root of 3 over 3. And if we write this in a little bit better format, then we get 3 minus the square root of 3 all over 3. So we've got the common denominator in the top. If we simplify it with the common denominator in the bottom here, we get 3 plus the square root of 3 over 3. And then let's go old school. So this is 3 minus the square root of 3 over 3 divided by 3 plus the square root of 3 over 3. When dividing, don't ask why. Flip the second one and multiply. So this is 3 minus the square root of 3 divided by 3 times 3 over 3 plus the square root of 3. And what happens here is that the 3's cancel out. 3 divided by 3 cancels out. And we end up with 3 minus the square root of 3 over 3 plus the square root of 3. Pause the video for a minute because some people were wanting to cancel out the 3's in this expression. And so down below it, what I want to show again, actually I'm going to erase it and show it here on video, is that when you multiply the tops together and we multiply the bottoms together. So when we do that, what happens is we get 3 times 3 minus the square root of 3. And down here in the bottom, when we multiply, we get 3 times 3 plus the square root of 3. And then what happens is that these 3's cancel out, and that's where I got that value right here. We cannot cancel out anything else. The rest of it cannot be factored, and in general, if we can't factor, we can't cancel. So what we have now is we have 3 minus the square root of 3. Divided by 3 plus the square root of 3. And you might want to have a piece of notebook paper if you're finishing this problem down, because you're probably starting to run out of space on your notes here. But what happens now is that we have a radical in the denominator, and we're not supposed to have a radical in the denominator. So what we need to do is we need to multiply by the conjugate. So we're going to multiply by 3 minus the square root of 3. If we multiply the bottom of our fraction by 3 minus the square root of 3, we're going to multiply the top by 3 minus the square root of 3. And that's a fancy form of 1, is what we're multiplying by. And now what we're going to do is we're going to FOIL. So we end up with 9 minus 3 times the square root of 3 minus 3 times the square root of 3 plus the square root of 9. Some of you I know won't write that down, but it never hurts for me to show every single step. In the denominator, we get 9 minus 3 times the square root of 3 plus 3 times the square root of 3 minus the square root of 9. And no, you cannot cancel top and bottom anywhere in this problem, at least not so far. The one thing that I notice is that this and this cancel out because they're opposites. Coming back around here, what we have left with a little bit of simplifying now is we have 9 minus 6 radical 3. We've got negative 3 times the square root of 3 minus 3 times the square root of 3, which is minus 6 times the square root of 3. And over here then it's plus the square root of 9, which is the same thing as plus 3. In the denominator, we've got 9 and minus the square root of 9, we've got the square root of minus 3. So we're getting closer now. If we simplify up here in the numerator, we've got 12 minus 6 radical 3 divided by 9 minus 3, which is 6. And finally, when we simplify this, 12 and 6 all have something in common. So when we simplify there, we can divide everything by 6. So 12 divided by 6 is 2, and 6 divided by 6 is 1 times the square root of 3. And finally here, after all of that, we have used our tangent of pi over 4 minus pi over 6 to figure out what the exact value of tangent of pi over 12 equals.